What do you do when you have an uneven sample size? In other words, like on this example, we had 225 samples on the first subgroup. We had more or less on every other subgroup after that. Well, there's 2 or 3 different approaches to this that I'm going to show you. So here's one option. One option is, and I think this is my favorite, because it makes interpreting the control chart so much easier, whereas the next method, you kind of have to take every control limit and observation with a grain of salt, and you'll see why in a little bit. With this one, you don't. This one's funky, though, because you'll end up with a control limit that looks like this. Upper control limit, lower control limit. Isn't that weird? And this would be your center line. Center line. But the point is, you calculate the control limit for every single observation. You do it for the lower control limit, and you do it for the upper control limit. It makes sense, right? Because n is what is varying. Okay. The other method is to basically take the average of whatever the sample size is and put that wherever n is in those formulas. Let's move on to fish sticks. A company manufacturing fish sticks samples an average of 300 fish sticks every day. Sign me up. I love fish sticks. Get some big bottle of ketchup. Why not? However, the number of fish sticks examined for nonconformities per day varies. Data for the previous 25 days is shown below. Calculate the central line and control limits for the first 3 points. So here's an example where sample size of the first one is 313, and it's 295. So here, I've given you an example with these fish sticks, unlike the previous one, where if you wanted to practice this on your own and see the actual solution, how did we get that p-bar? Well, we're just adding up all of these p's, np's, 19 plus 14 plus 17, divided by all of these n's. So 305 is, how many we had in this column, and 7,612 is how many we had in this column. So that gives us p-bar. So now we drop 0.04 plus or minus 3 times p times 1 minus p divided by n. The big question, though, is what do you put for n? Okay. But for this first observation, for the first subgroup, we're going to use 313 for n right here. So that gives us the control limits for the first point. And the control limits will be different for the second point and the third point. And this is what it looks like for you. Okay? So see how it looks wonky because you don't get that straight line that you saw with all the variable control charts. But you know if it's out of control or outside the control limits in this case. In this case, we don't see any outside the control limits. However, let's just have a brief chat about any patterns you might see. If someone said, here's our control chart, and they said, we don't have any points out of control. Now that you're taking this class, you would say, yeah, I don't know, let me think about that. I agree there aren't any outside the control limits, but let me see if I can find any patterns. Do we have 2 populations? Not really, because we don't see a bunch hugging the top line and a bunch hugging the bottom line. Do you see a cycle? Yeah, maybe. It kind of goes down and then, yeah, I don't know. What other patterns have we talked about? Do you see a steady increase? Not really. Steady decrease. Do you see a jump? Yes. At subgroup 7, it jumps to subgroup 8. That's how I would read it anyways. Obviously, it's subjective. Okay, so here's to illustrate that when you have a bigger n, the control limits are tighter. That makes sense, right? If you just kind of think about it conceptually. Whereas if you don't have as many samples, the control limits are farther apart. If instead you wanted to be, maybe not go through all the work, or you didn't have the computer to punch in 295, 311, put in that n in the denominator for all 25 subgroups, you could just put the average n in there. And so if the total n was 7,612, because remember, this equals the sum of np divided by the sum of n. So if sum of n equals 7612, and there are 25 subgroups, what is n bar, basically? What is the average n? How would you get that? 7612 divided by, if we want to know the average n for all 25 subgroups, we're going to punch in 25, right? So that's how you would get n bar, and then whatever this is, you would punch that in the denominator instead. Depends on your philosophy. Would you rather, are you one who wants to get every single observation, so you just, you have more control over the control chart, or do you want to just kind of punch in that average n, and this is what this control limit would look like. Same story, fish sticks. But now, instead of a control chart that looks like this, we have a control chart that looks like this. Looks cleaner, but now you're going, yeah, I don't know. Let me take it with a grain of salt. Average n is 304. But what was the sample size for the first subgroup? Do you remember? Yeah, 313. You see where I'm going with that? Because this is not the true control limit. It's just it's the average. So now you have to just you're eyeballing it, but you're going, wow, what was if the sample size was bigger, then it's going to be closer to the center line. If it was smaller, the control limit was actually, in reality, farther away from the control limit. So